Hello viewers, welcome to another video. Now today we have another question on thermal physics, and the question reads: a 40-gram ice cube floats in 200 grams of water in a 100-gram copper cup. All are at a temperature of 0 degrees Celsius. A piece of lead at 98 degrees Celsius is dropped into the cup, and the final equilibrium temperature is 12 degrees Celsius. What is the mass of the lead? Now, this is the way the question is, okay? And we are not provided with the value for the specific latent heat of fusion of ice, and also the value for the specific capacity of water, and also the value for the specific capacity of the copper cup and that of the lead. Okay, it is not provided. This is the way the question is. So now, for engineering students and also physics students, okay, one thing is important here, and what is important here is at all time when it comes to areas involving most especially nuclear physics, thermal physics, electromagnetic waves, and when we talk about electricity and magnetism, there are some values that we use often, and these values, because we use these values often, so it is always important to know all these values, so that when let's say when you come across questions where these values are not given, and those values will be required in order to solve the problem, then that means without those values you won't be able to solve the problem. All right, so in this case, now we have a 40-gram ice cube, okay, float in 200 gram of water in a 100-gram copper cup. Okay, now in a 100-gram copper cup, first thing first, we have mass of ice, which is 40 grams. Then we also have mass of water, which is what? 200 grams. And then we also have mass of copper. The mass of copper is given to be 100 grams. So a piece of lead at 98 degrees Celsius is dropped into the cup, and the final temperature is 12 degrees Celsius. Now, first we need to understand that this 0 degrees Celsius, okay, is the first temperature of water, ice, and cup. That is the initial temperature. That is the starting temperature. So the initial temperature, so we have the temperature of ice is the same thing as the what? Initial temperature. That is first temperature. This is the first temperature of ice, water, and the cup. Now, so we are given here that the temperature of the lead, okay, the piece of lead is 98 degrees Celsius, okay, before it is now dropped into the what? Into the cup containing mixture of ice and water, okay, is 98 degrees Celsius. Then the temperature of the ice, water, and the cup, now increases from 0 degrees Celsius to 12 degrees Celsius. So which means now we have the final temperature, okay, the final temperature of ice, water, and cup, okay, that is the mixture, okay, is what we have as 12 degrees Celsius. So now temperature, we have the temperature of the hot lead, lead, that's plumb, okay, PB, that'll be 98 degrees Celsius. Now let me explain this. Now we have a cup. This is a cup. Inside the cup is water, and the mass of water is 200 grams. Then we have ice, okay, ice floats in the 200 grams of water, which is in the cup. So the mass of ice is given to be 40 grams. That's 40 grams. The mass of the ice is given to be 40 grams. That's a cup. So this is water. Okay, this is water. Now, then also let's say we have a boiling tube. A boiling tube. This is a boiling tube. And the boiling tube, okay, we have it on a fire gaze or the Bunsen burner like this. Okay, so we have the Bunsen burner. This is the Bunsen burner. So that's the heat source. So now the boiling tube, okay, is filled with water. Thus, we have water placed in the boiling tube. And also, we now again have, this is the lid block or the lid, okay? The lid, this is the lid. The lid is, the lid is immersed in the water, thus, it is immersed in water contained in the what? The boiling tube. So now, when the water boils, when the temperature of the water reaches 98 degrees Celsius, now then the lid is quickly what? The lid is removed and then what? And then dropped into the cup containing ice and water mixture. Okay. So when the lid is dropped here, the temperature of the lid, from the when it is transferred from the boiling tube into the cup containing water, the lid temperature is 98 degrees Celsius. So the lid is going to lose heat, okay, when it is dropped into the cup containing water and ice mixture, okay. When a stirrer is introduced, in this case, this is stirrer, okay, we have the stirrer introduced, okay. So when a stirrer is introduced and the mixture is stirred thoroughly in order to aid equilibrium temperature or even temperature, now the cold substance will absorb heat, okay, will absorb heat, while the hot substance, which is the lid will lose heat, okay. So, and when it lose heat, its temperature will drop from 98 degrees Celsius to this temperature, which is 12 degrees Celsius. So now we want to find out the mass of the lid. So to be able to calculate the mass of the lid, so let's write mass of lid. Mass of lid. This is not given. So the first thing we need to do, which is our first inclination, is to what? To calculate the heat gained by the ice to melt and reaches 12 degrees Celsius. When the ice melts, the melting temperature of ice is 0 degrees Celsius. So in that case, because it melts, that is, it convert from its solid state into what? Into liquid state. In that case, we are going to what? We are going to make use of what we call, and that's the heat gained by the ice. Okay, so we have the heat gained. Okay, the heat gained by the ice. Okay, heat gained by the ice, that's heat gained by the ice to melt and reach 12 degrees Celsius will be, so the heat gained by the ice will be, that's mass of the ice multiplied by the specific latent heat of fusion of ice, then plus mass of ice, okay, multiplied by specific capacity of water, then multiplied by temperature difference. Okay, so in this case, mass of ice is 40 grams. Okay, mass of ice is 40 grams. What is now the specific capacity? That is the specific latent heat of fusion of ice. Now, the specific latent heat of fusion of ice is 334, joules per gram. 334 joules per gram. Then the specific capacity of water. The specific capacity of water is 4.18 joules per gram per degree Celsius. Joules per gram per degree Celsius. That's specific heat capacity of water. Okay, which other one are we not giving? Okay, specific heat capacity of copper. The specific heat capacity of copper is the specific capacity of what copper is 0.385 joules per gram per degree Celsius. Yeah. Then also for lead, the specific heat capacity of lead, that will be specific capacity of lead is 100 and 0. Yeah, specific heat capacity of lead, yeah, that will be 0.128 joules per gram per degree Celsius. Yeah, that's it. All right, so we have heat gained by ice to be 40 multiplied by 334, 40 multiplied by 334, then plus 40 multiplied by specific capacity of water, which is 4.18. Now the temperature difference, I said this is the total heat gained by the ice to melt. So for the ice to melt, it will be mass of ice multiplied by latent heat of fusion of ice, okay, which is 334. Then plus the heat gained by ice warming. That is when the temperature of the ice increases from 0 degrees Celsius to 12 degrees Celsius. So that means the temperature difference would be 12 minus 0. So this would be, so the heat gained by the ice would be, so what is 40 multiplied by 334? That will be 133.60. Okay, that will be 133.60 plus. Now let's get the value for 40 multiplied by 4.18, then multiply by 12. 40 multiplied by 4.18 multiplied by 12. That's 2006.4. Okay, so we have 2006.4, and this will be in joules. Okay, so when this is added to 13360, then that will be 15366.4. So the total heat gained by ice is 15366.4 joules. This is the total heat gained by ice. This is the total heat gained. Total heat gained by ice block. Ice cube, rather. Ice cube. By the ice cube. That's for the ice. Now let's also calculate the heat gained by water. Now water also gain heat because when the lid is dropped into the cup, okay, containing water and ice mixture, okay, the water will absorb heat, and that means its temperature will increase from 0 degrees Celsius to what? To 12 degrees Celsius. So in this case, so we have heat gained by water, okay, heat gained by water, okay, that will be mass of water multiplied by the specific heat capacity of water, then multiplied by temperature difference. So mass of water. So the mass of water is what we have here as 200 grams. Then we multiply it by specific capacity of water, yes, which is 4.18 joules per gram per Celsius. Remember, all units are given in what? CGS. So that's why it does the specific heat capacity of water has to be what? 4.18 joules per gram per degree Celsius. So in this case, when we're going to multiply this by 4.18, then multiply by 12 minus 0. So this will be 200 multiplied by 4.18 times 12. Okay, so 200 multiplied by 4.18, then multiply by 12. That is 132. That is going to be 10,032 joules. So that is the heat gained by water. Remember, water ice and the cup gains, that is, they absorb heat, while the what? The lid loses what? Heat. So also we also need to what? To calculate heat gained. Heat gained by what? By copper cup. So the heat gained by the copper cup, okay, the heat gained by the copper cup. Heat gained by the copper cup will be, so it will be mass of copper multiplied by the specific heat capacity of copper. Specific capacity of copper multiplied by the temperature difference. That is the word, the temperature difference, or temperature rise, or the difference in temperature. All right, so in this case, so this will be the heat gained by the copper cup will be equals to mass of copper, which is 100 grams. Then we multiply that by the specific heat capacity of copper. These values are very important. Okay, these values are very important. Remember, when these values are not given, okay, it means you are expected to what? You are expected to know the value. So it is important. So the specific capacity of copper is 0.385. 0.385, then multiply by the temperature difference, which is 12 minus 0. So this will be equals to 100 multiplied by 0.385 times 12. So 100 multiplied by 0.385, then multiply by 12. That will be 462. So this is in joules, remember. So the heat gained by copper will be 462 joules. 462 joules. So in this case, so we are now going to calculate the total heat gained by water, water, ice, and cup. So total heat gained by water, ice, and the copper cup, okay, the copper cup would be, the total heat gained will be this value. Remember, we got the heat gained by water to be this, and then the heat gained by copper cup to be this. So all of that will be added. So we have 15366.4 plus this value 10032, then plus 462. So let's add all these values together. So 462 plus 10032 plus 15366.4. 15366.4. That will be 25860.4. So the total heat gain is 250. That's 25,860.4 joules. This is the total heat gained. So remember, total heat gained is this value, 25,860.4 joules. Now, according to the principle of calorimetry, now we know that heat lost by hot substance will be equals to heat gained by cold substance. So that means the lead, okay, which is the hot lead, which is what transferred into the cup containing ice and water mixture, okay, loses heat. Okay, so which means heat lost, we know that heat lost is equals to what? Heat gained. So we know that the total heat gained is 25860.4 joules. So the heat lost, okay, the heat loss will be mass of lead multiplied by the specific heat capacity of lead, then multiplied by the temperature difference. Now the temperature difference in this case will not be 12 minus 0. Why? Because now the first temperature of the lead, like I said, now water in this case boil at 98 degrees Celsius. So the boiling temperature of water is the same as the temperature of the lead. So which means the temperature of the lead will be 98 degrees Celsius. So the lead is then transferred into the cup containing water and ice mixture, okay, before it now drops to 12 degrees Celsius after the stirrer. After stirrer is what? Introduced. Okay, you know, when stirrer is introduced to what? To stir the mixture thoroughly in order to what? To aid even or equilibrium temperature. Then thermometer will now be introduced. You know, thermometer will be introduced into the what? The content, all right, to measure, to read and record the new temperature. And the new temperature recorded is what? 12 degrees Celsius. 12 degrees Celsius. Videos I'll be doing about thermal physics. We'll be looking at adiabatic process, isentropic, isothermal, and the rest. Okay, and then we'll see how all of these things, you know, and we also look at some real world problems, you know, when it comes to thermal physics. All right, so then in this case, the temperature will be the first temperature, which is 98, then minus 12. That's the temperature difference. So in this case, so we have mass of lead multiplied by, now the specific heat capacity of lead, we have that to be 0.128 joules per gram per degree Celsius. So it's 0.128, okay, 0.128 multiplied by, this will be 86. So 0.128 multiplied by 86, that will be, when multiplied by mpb, that's mass of lead, it will be 11.008, then mass of lead. So this is the heat lost. So heat lost equals to what? Heat gained. So heat lost is, so we have heat lost to be equals to heat gained. And then the heat lost is what we have as 11.008 mass of lead equals to, then the heat gained is 25860.4 joules. So now we can then calculate the value of mpb, that's mass of lead. Mass of lead in this case will be 25860.4, okay, in joules, okay, divide by 11.008. The unit will be in what? In grams. The unit will be in grams. So when this is in joules, then the other one will be in what? In joules per gram. So then the unit will be what? Will be in grams. So that will be mass of lead equals to 25860.4, 25860.4 divided by 11.008, and that's what we have here as 2349.2. Then the mass of lead will be approximately 2349, and this is the mass of lead in grams. Remember, when this is converted to kilogram, it will be 2.349 kilograms. So this is the mass of lead, which is what we are looking for in the question. The noblest pleasure is the joy of understanding. Bye bye.